The World Wide Web, or simply the web, has revolutionized how we communicate and access information. It has transformed our daily lives, making it easier to connect with others, share knowledge, and access a wealth of information at our fingertips. It's a vast network of interconnected documents and resources, linked through hyperlinks and URLs. These links create a web of information that is easily navigable, allowing users to jump from one piece of content to another seamlessly. At its core, the web relies on a set of protocols and technologies that enable seamless data exchange between computers worldwide. These protocols ensure that data is transmitted accurately and efficiently, making the web a reliable platform for communication and information sharing. Understanding these foundational elements is crucial for anyone seeking to delve deeper into web technology and information gathering. By learning about the underlying technologies, one can better appreciate how the web functions and how to utilize it effectively. Imagine the web as a bustling city, with data packets as its inhabitants. These packets carry pieces of information traveling from one location to another, much like people moving through a city. These packets travel across the information superhighway, following established routes and traffic rules to reach their destinations. The journey of these packets is guided by protocols that ensure they arrive safely and in the correct order. Just like a city's infrastructure, the web relies on protocols to ensure the smooth flow of information. These protocols act as the rules and guidelines that govern how data is exchanged, ensuring that everything runs smoothly. These protocols dictate how data is formatted, addressed, transmitted, and received, forming the backbone of our online interactions. They are essential for maintaining the integrity and efficiency of the web, allowing us to communicate and access information effortlessly. Two fundamental protocols govern data transmission on the web: TCP and HTTPS. TCP, or Transmission Control Protocol, acts as a reliable delivery service, ensuring that data packets arrive at their destination in the correct order and without errors. Think of it as a meticulous postman, carefully assembling and verifying each piece of mail before delivery. HTTP, or Hypertext Transfer Protocol, defines how web browsers and servers communicate. It sets the rules for requesting and delivering web pages and other resources. HTTPS, the secure version of HTTP, adds a layer of encryption, safeguarding sensitive information like passwords and credit card details from prying eyes. This encryption is essential for secure online transactions and protects user privacy. For computers to communicate effectively, they need a shared language. This is where encoding comes in. Encoding converts data into a format that can be transmitted and understood across networks. Different encoding schemes serve different purposes, like ACI for basic text or UTF-8 for representing a wider range of characters, including emojis. Imagine encoding as translating a message into a code that only the recipient can decipher. Without proper encoding, data can become corrupted or misinterpreted during transmission. This can lead to garbled text, broken images, or even application crashes. Ensuring data is correctly encoded is essential for a seamless web experience. In the vast landscape of the web, the concept of origin plays a crucial role in security. Origin refers to the combination of a website's protocol, domain name, and port number. It acts as a digital fingerprint, uniquely identifying a website's source. Web browsers use the same origin policy to prevent malicious websites from accessing sensitive information stored by other websites. This policy ensures that a script from one origin cannot access data from a different origin without explicit permission. It's a fundamental security mechanism that protects users from cross-site scripting attacks and other web-based threats. Section 5. Cookies and Sessions. Managing User Interactions. Cookies and sessions are essential mechanisms that websites use to enhance user experience and manage user interactions. They play a pivotal role in how users navigate and interact with websites, ensuring a seamless and personalized experience. Cookies are small text files stored on a user's computer by websites they visit. These files can store a variety of information, from user preferences to login details, and even tracking data for analytics purposes. They contain information about user preferences, login details, and other data that websites use to personalize content and track user activity. This personalization can include remembering language settings, themes, and other user-specific configurations. Sessions, on the other hand, are temporary data stores on the server side that track a user's activity during a single visit. Unlike cookies, sessions are not stored on the user's device but are maintained on the server, providing a more secure way to manage user interactions. They are commonly used for tasks like maintaining shopping carts, remembering user preferences, and managing login sessions. For instance, when you add items to an online shopping cart, sessions ensure that your selections are remembered as you navigate through the site. Proper management of cookies and sessions is crucial for both user experience and security. Mismanagement can lead to issues such as data breaches, loss of user trust, and potential legal ramifications. Websites must ensure that sensitive information stored in cookies is properly encrypted and that session IDs are protected from hijacking attempts. Implementing robust security measures such as HTTPS and secure cookie attributes can help safeguard user data and maintain the integrity of user sessions. Section 6. Fingerprinting web servers and applications. Just like every individual has unique fingerprints, web servers and applications also possess distinct characteristics that can be used to identify them. This process, known as fingerprinting, involves analyzing various attributes of a web server, such as its operating system, web server software, and configuration settings. Ethical hackers and security researchers use fingerprinting techniques to gather information about potential targets, identify vulnerabilities, and assess security posture. Tools like Nmap, Shodan, and WhatWeb automate this process, providing valuable insights into the underlying technologies and potential weaknesses of web servers and applications. Section 7. Unmasking hidden services, subdomains, and virtual hosts. In this section, we will delve into the fascinating world of subdomains and virtual hosts, exploring their significance and applications in web hosting and development. Subdomains and virtual hosts allow a single domain name to host multiple websites or services. This capability is essential for businesses and developers who want to manage various sections or entirely different websites under one umbrella. Subdomains are extensions of the main domain name, often used to organize different sections of a website. They help in creating a structured and user-friendly navigation experience for visitors. For example, blog.example.com could host the blog section of the example.com website. This separation allows for better content management and can improve the overall performance of the main site. Virtual hosts, on the other hand, allow multiple websites with different domain names to share the same IP address. This is particularly useful for hosting providers who need to maximize their resources efficiently. This technique is commonly used by hosting providers to host multiple websites on a single server. It enables cost-effective hosting solutions and simplifies server management. Understanding subdomains and virtual hosts is crucial for ethical hackers and security researchers, as they can reveal hidden services and potential attack vectors. By analyzing these elements, security professionals can uncover vulnerabilities and strengthen the security posture of web applications. Section 8. Exploiting misconfigurations. Misconfigurations in web servers and applications can create significant security vulnerabilities that attackers can exploit. These misconfigurations can range from improper access controls and insecure default settings to outdated software and missing security patches. Attackers use various tools and techniques to identify and exploit these misconfigurations. Port scanners like Nmap can detect open ports and services running on a server, while vulnerability scanners like Nessus and OpenVAS can identify known vulnerabilities in software and configurations. Ethical hackers use these same tools to proactively identify and remediate security issues before they can be exploited. Section 9. Google hacking. An ethical perspective. Google hacking, also known as Google dorking, is a technique that leverages Google's search operators to discover sensitive information that is publicly accessible, but not intended for public consumption. These search operators allow users to refine their searches and uncover specific types of information, such as exposed configuration files, vulnerable web applications, and publicly accessible databases. While Google hacking can be used for malicious purposes, ethical hackers and security researchers use it to identify and report security vulnerabilities, helping organizations improve their security posture. By understanding how attackers use Google hacking, ethical hackers can proactively identify and mitigate potential risks. Section 10. Conclusion. The world of web technology and information gathering is vast and constantly evolving. Understanding the fundamental protocols, encoding schemes, and security concepts is crucial for anyone seeking to navigate this digital landscape. From the foundational roles of TCP and HTTPS to the intricacies of fingerprinting and the ethical implications of Google hacking, each concept provides valuable insights into the workings of the web and the importance of cybersecurity. As technology advances, so too will the methods of information gathering and the challenges of securing online assets. Continuous learning and a commitment to ethical practices are essential for anyone seeking to explore the fascinating world of web technology and information security.